Hello everyone, welcome back to another video lecture on basic algebra. Today we're going to be talking about distance formula. So the distance formula is actually used to find the shortest distance between 2 points in space. So before we talk about the actual distance formula and what the formula is, let's talk about how it came about. So many of you know the Pythagorean theorem. Pythagorean theorem is based on the idea of a right triangle with sides A and B and a hypotenuse of C. Now the Pythagorean theorem says that a squared plus b squared equals c squared. But if we were to look just for c, we would use c equals the square root of a squared plus b squared. Now the distance formula kind of comes off of the idea of this by setting our 2 points here and here at the two ends of the hypotenuse. And this would be some point x1, y1, and this would be another point x2, y2. So let's talk a little bit about these distances for A and B. Consider we had 2 points on a graph, and we wanted to just find their horizontal distance. So let's just grab 2 points and find the distance between these 2 points. So this point here is -3, 3, and this point is 1, 2, 3, 4, 5, 6, 7. This is 7, 3. And if we counted the distance between these, you'd see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a distance of 10 units. And notice that the y doesn't change, so we only really need to worry about our x and this horizontal distance. So if we took the difference between these, 7 minus -3, well, that equals 10. And that's the horizontal distance that we have. So let's consider now calculating y distance, or vertical distance. So if we look here, we have 2 points, 2, -2, and 2, 6. So their x values are the same, and it does not change at all horizontally, only vertically. So if we calculated the vertical distance, we'd see it's 1, 2, 3, 4, 5, 6, 7, 8. So this has a distance of 8. And if we looked at this and took their difference, we'd see it's 6 minus -2 equals 8. Now let's try looking at a set of points that are not on a straight line with each other. Or I should say, not horizontally aligned or vertically aligned. They can be connected via a slanted line, like so. And that is the distance that we're actually looking for. To find this distance, we are going to start the creation of the distance formula. So first, let's look at the horizontal and vertical distances that we have. And you can see here, if you connect these like so, you can actually draw a right triangle and use the Pythagorean theorem. Now this distance here, we could call this A, call this B, and call this C, and that would give us the Pythagorean theorem, right? That gives us, to find C, we would do A squared plus B squared equals C squared. But to actually find A, B, and C, we have to take the distances to this point from the other two. Now if we look at this, this is actually the point 9, -1. it actually shares the same x value as this point and the same y value as this. So let's calculate our a and b so we can find c. So if we start here, we'll go across this way. This has a distance of 9 minus negative 3. So that is actually 9 plus 3, which equals 12. Next, we calculate the height distance, the vertical distance here, or y distance. We go from negative 1 to 8, so that's 8 minus negative 1, which is the same thing as 8 plus 1, which equals 9. So this tells us that 12 squared plus 9 squared equals c squared. We would square root both sides to find c. c equals the square root of 12 squared plus 9 squared. This is the square root of 144 plus 81. And this equals, let's see, 144 plus 81 is 225. Oh yeah, look at that. Square root of 225, which should be 15. So you see here, that means that this distance here is 15. So instead of doing it all long, like what we just did here, there's a shorter way to do this, and this is where the distance formula comes in. So the actual distance formula is written as distance equals square root of x2 minus x1 squared plus y2 minus y1 squared. And if you look at this example that we did here, this distance is x2 minus x1, the 9 minus the negative 3, and this distance was y2 minus y1, which is 8 minus negative 1. So here we have our distance formula, and if we were to put it in, take those same points that we did earlier, say 9, negative 3, negative 1, negative 1, and 9, 8. This would be square root of 9 minus negative 3, 9 minus negative 3 squared, plus 8 minus negative 1 squared. 9 minus negative 3 is 12, 12 squared, plus 8 minus negative 1 is 9, 9 squared. 144 squared, or 144, plus 81 equals root 225, which is just 15. And it gives you the same thing without having to draw a picture. Now, you might wonder, does the order of these matter? Well, here we had 9 minus negative 3, and we squared that. Well, what if we did it the other way around and said negative 3 minus 9 squared? Negative 3 minus 9 squared. Well, negative 3 minus 9 gives you negative 12 squared. But since this negative is inside the parentheses, and then you're squaring it, this is still positive 144. Similarly, if you did negative 1 minus 8 squared, this is going to give you negative 9 squared, which is still positive 81. So you see, it doesn't matter which order you put them in, but you want to keep your x's with their y's grouped properly. So you want to keep negative 3 and negative 1 grouped as the first, and 9 and 8 as the second, or 9 and 8 is the first, and negative 3 and negative 1 are the second. So you see here, we had 9 and negative 3, the first x, second x, first x, and then over here we did 8, negative 1. So 9 and 8 were first, were the second x and second y. Negative 3 and negative 1 were grouped together as the first x and the first y. When we did it on this side, we did negative 3 grouped with negative 1 as our second, and our 9 and our 8 as our first. So as long as you keep them grouped together, that's all that really matters. So we could, while doing this, find the distance and the slope between these 2 points. So suppose we have 2 points, negative 3, 4, and 2, negative 2. And we wanted to find their distance and their slope. So first we would say, set our pairs as x1, y1, x2, y2, and we would say the distance equals the square root x2 minus x1 squared plus y2 minus y1 squared. x2 is 2. It's 2 minus x1 is negative 1, or negative 3, sorry. Then y2 is negative 2. y1 is 4. This gives us 5 squared plus negative 6 squared. This is root 25 plus 36. This gives you the square root of 61. And the square root of 61 is about 7.8. 7.81. So our distance is 7.81. And if we were to work out our slopes, we have the 5 and the negative 6. Our rise is going to be negative 6. M equals rise over run equals delta y over delta x, which would be negative 6 over 5. So in doing this, we can kind of find both the slope and the distance, because another way to write our distance formula is simply as distance equals the square root of delta x squared plus delta y squared. Delta x and delta y are found the same way. It's simply y2 minus y1 for delta y, and x2 minus x1 for delta x. So I hope that you learned a bit about the distance formula here. Thanks for joining us for this video. I'll see you in the next.